It is given that boiling water at 100 degrees Celsius and cold water at T degrees Celsius are mixed in the ratio 1:3, and the resultant maximum temperature was 37, assuming no heat losses. The value of T is. So over here we are considering mixing of two liquids, and in question it is given that a boiling water, so this is water at 100 degrees Celsius, and a cold water at T degrees Celsius are mixed in the ratio 1:3. That means if its mass, if we are taking it as m, then mass of this one we can take it as 3 times of that 3m. And the resultant maximum temperature was, so the equilibrium temperature of the system we are getting it as something about 37. Assume now heat loss, the value of T is. So we can say that there will be a transfer of heat energy from high temperature region to low temperature region, and we'll write the heat loss by the hot body as equal to heat gain by the cold body. Or you can write this ms delta T of heat loss is equal to ms delta T of heat gain. Now mass in the first situation we can write as m, specific capacity of water is 1, or you can take it as nothing but s, and delta T over here, initially it was 100 and now it is 37. So you can write the difference in temperature is 100 minus 37, and which is equal to, on the right hand side we can write mass is 3m and specific capacity is nothing but s, and delta T, it is initially it was T and now it is 37. So 37 is greater than T, so we can write this is nothing but 37 minus T. Now we can find out what about the value of this T over here. We can cancel this m and this m, and this s and this s. This 100 minus 37 we can take it as 63 is equal to, we can write 3 times of 37 minus T. So this 3 and this one get cancelled, which we can take it as something but 21. So 21 is 37 minus T, so the value of T can be written as nothing but 37 minus 21, which we can take it as nothing but 16.